Day 11, we're going to look at loans and investments and how you can use recursion to explore these different situations. So here's the main problem for today. You plan to borrow $22,000 from a bank to buy a new car. Okay, I'm going to underline that because it seems like important. Actually, we'll highlight it. You will make a payment every month to the bank to repay the loan, which must be paid off in 5 years or in 60 months. The bank charges an annual interest rate of 3.9% compounded monthly. Part of each monthly payment is applied to the interest, and the rest is applied to reduce the starting balance or the principal. So what this means is you need the money, right? So you get the loan from the bank. They charge you interest to borrow their money, so they're making money off of you. So every month you have your monthly car payment, and again, some of it goes towards the interest, like towards to the bank for holding or for lending the money out for you, and then part of it goes off, like to pay off this initial balance of $22,000. So we're going to figure out, like, what's the monthly interest rate, what is the first month's interest on $22,000, so how much is going towards the bank and how much is going towards the car. So let's talk about how we calculate that. The monthly interest rate, we're going to take the yearly rate, which is 3.9%, and change it to a decimal. So divide by 100, or move the decimal over twice. And then that's the yearly rate. So if we divide by 12, we'll get the monthly rate. So that is 0.00325. So every month you're paying about 0.325%, so that when you add it up at the end of the year, you're paying that 3.9% interest. So to figure out after 1 month, how much is going towards the bank? It says, what is the first month's interest on $22,000? So we'll take that answer, and we're going to multiply it by $22,000. And this is just the interest, like when you pay it down, this is what goes towards the bank. The bank on the first month makes $71.50 off of you. So this is just the first month. This amount goes towards the bank, and the rest of your payment goes towards paying off your car. So it says if you make a payment of $300 at the end of the first month, what's the remaining balance? Okay, so what we're going to do is we're going to write an equation to figure out the remaining balance. Okay, so here we go. We have that $22,000 that we owe plus the interest. Okay, so you took out the loan. They're charging you 3.9% interest compounded monthly. So now you owe $22,071.50. But then you're making a payment of $300. So at the end of the first month, the remaining balance on the car, we owe $21,771.50. Okay, so again, making that $300 payment, some goes towards the interest on your loan and some goes towards the actual first payment, our first initial loan, and this is how much we owe after 1 month. It says record the balances for the first 6 months with monthly payments of $300. All right, let's come up with a recursive formula. So our initial payment, A sub 0, or initial amount that we borrowed, is our $22,000. To find the amount that we owe after each month, A sub n, we take the amount that we owe the month before, but then we're going to multiply it by this interest rate, which increases at 0.039%, or 3.9%, but change to a decimal, divided by 12. And then we're going to subtract, so this is how much it goes up by, but then we'll subtract our $300. And then every month we do that. We calculate the interest on what we owe, but then we subtract our payment of $300. So the balances for the first 6 months, we can program this into our calculator like we did yesterday with the shifted geometric. This is also shifted geometric. We also can use a spreadsheet to calculate that. So let's actually try doing that on a Google Sheets. And you can do it in Excel as well, but I think everyone has access to Google Sheets. So I'm just going to pull that up. Okay, so let's write a program so we can just calculate really quickly, after 6 months, how much we owe. All right, so I'm just going to open up a spreadsheet. And I'm just going to put our starting value, I'll put it over here. Okay, so there's our starting value. And then I'm going to put the equation in this first row. So for an equation in Google Sheets, we'll put equals. And then I'll put parentheses here. I don't know if I need it, but this value, so this is the month before, this is A sub n minus 1. And we're going to multiply it by that interest rate, which is increasing at 0.039 divided by 12. Okay, so we're going to do that. And then I think here we can subtract the 300. I believe this will work. and we can check our answer. So here it is. We can check our answer because we have that amount right here. Oh, good, that matches. Okay, so now what should happen is that's the amount we owe after 1 month. So now I should be able to pull down from here. Let's see if it works. And see how much we owe after 6 months. Nope. Okay, so, and the reason is maybe this cell right here. I wonder if I start in this first cell. Okay, so here's what we're going to do. I'm going to put the 22,000 here. I think maybe it has to be in the same row. And then I'll do that same program. So we'll take the answer from the previous time, multiply it by that increasing rate of 0.039, but it's monthly. Okay. And then I don't know if I put the minus 300 here or if I put it after the parentheses because I have 3 open. I'm going to try it here. Okay, now if I pull down, does it work? Okay. So now this works. And so again, to pull it down, I have to start. So for 6 months, I'll start at where I put the program and then pull it down for 6 months. So here's after 1 month, 2 months, 3, 4, 5, 6. So here's 6 months, and we can see after 6 months how much we owe. So let's just write that down here. Okay, so after 1 month, our remaining balance is $21,771.5. After 2 months, it's $21,542.26 if I round. And if I round this one, I put 5, but it's 0.25. The next month, it's $21,081.53. The next month, it's $20,850.05. The next month, it's $20,000. Am I missing one? Okay, the first month, the second month. Oh, I missed the third month. Whoopsies. All right, so redo. The third month right here is $21,312.27. Then we have the $21,081.53, the $20,850.05, and the $20,617.81. Okay, so after half a year, we still owe $20,617.81. And again, we're trying to figure out, like, in this problem, what we're looking at is some of the money goes towards the initial car payment, the $22,000, but some goes towards the bank as well. So the question is, how long will it take to pay off the loan? And again, we want to pay this off in 60 months. And right now we've taken a look at 6 months. So what we're doing is I'm just going to pull down. Again, we have to start from our program right here. And I'm going to pull down until I go from like a positive balance, what we owe, to like 0 or close to 0 or a negative. So I'm just going to pull down. So for example, let's take a look at 60 months because we want to pay it off in 60 months right here. So this program will calculator. And again, 60 months really in my program is 61 because I used the first. Okay, so you can see after 60 months right here, we still owe $6,888.99. So we are not able to pay this loan off in 60 months. So how long will it take? So let's just guess. Let's try like 70 months. Is it paid off? Nope, we still owe $4,000. So again, we have to pull down for the beginning. Let's try 80 months. And actually 80 months is at 81. Okay, so after 79 months, we still owe money. So we'll keep pulling down until we get from a positive to a negative. I'll just go past. Oh, okay, so negative, which means we paid it off. So now let's take a look. When does it go from positive to negative? And it's between, and really this is the 80, because this is, we started one back. So between the 83rd and the 84th month. So this is the 83rd month because we started at month 1 when I should have started month 0. And this will be the 84th month. So after 84 months, we finally pay off the car, which is much too long. All right, so our goal here now is, part of your assignment then is, can you experiment with other values for loan payments? What payment allows you to pay off the loan in exactly 60 months? So what that means is, when you pull down your program, you want to go from positive to negative. And again, remember we started at like month 1. So here, like month 2 is really month 1. So what we're looking at is at 61 months. This is our goal. So 60 months, but 61 for us. At 61, your balance goes from positive to negative. But you have to experiment with different values. So in our program, instead of minus 300, let's make a bigger payment of 400 and see what happens. Oh, it recalculates it for us, so we don't have to pull it down. All right, so now let's take a look at, we're looking at month 61, which is really month 60. Oh, it's still positive. So what you're doing is you're trying to figure out the payment value. You're just changing this one number. What if we make a payment of 500? And again, it recalculates that for us. So let's take a look. Again, we're looking at month 61 as the goal. And you can see it's still a positive value. So your goal is to figure out what is the monthly payment so that we can pay it off. Oh, and did it change? Oh, no, it didn't change it. Okay, so we do have to re-pull it down. So here's the monthly payment of 500. You do have to re-pull it down. Okay, let's look at 61 months. Oh, okay, so we know that the payment of 500 pays it off at 48 months. Okay, so we know it's less than 500. So your goal is to change the program, pick any number here, like, I don't know, 480, but then you have to re-pull down this program to make it work, and you're looking at month 61. Does it change from positive to negative? So this payment's still too big. All right, so that's the goal for number 1 in your assignment. And then the rest of the assignment is review. So your goal is to finish up to, and it goes kind of on the next page, so 35 to 36 is your assignment, which we'll go over in class tomorrow.